Exercise 17. In this exercise, we're going to take a look at Creo Parametric 5.0 and its use of sheet metal when we design a part exclusively in the sheet metal module of the software. The part in front of you is what we're going to go ahead and build, and let's take a look at how this is done. I'm going to start off with a new part file, but be sure to select sheet metal, and then go ahead and name this capital E17 and hit OK. We're going to begin on the front plane, so in the model tree, click on it and go to Extrude. You might notice that the sheet metal tools up at the top have shown up here, but then we now see the sketch tools, which are pretty typical of when we're editing a part or in a part file. Let's begin with the line tool. Start off just a little bit to the left of the origin, click, drag a line and connect to the origin, make sure it's horizontal. Click again, drag straight up, and be careful not to automatically get equal. Equal is a nice automatic constraint, but we don't want it. So just make sure you just get the vertical line in the green box, click, and then an angled line. And again, make sure that there's no equal symbols. Click, and then middle click with your mouse button, the wheel in the center, just click one time. And then middle click one more time, actually. This will bring the dimensions up. Go ahead and change some of these dimensions from 5 inches by double clicking on this. This is going to be 4. And then this dimension needs to actually be parallel to the line. So go to the dimension tool, click on the line, not on the endpoints, and then move just a little bit above it in the middle and middle click and change that to 4. And then middle click 2 times. And if you have this dimension, go ahead and double click on it. It should be 115. If you don't have it, go to dimension this line and this vertical line, middle click where my 115 is, and you'll be able to put it in. Hit OK. Now you can see it immediately starts to make a solid, a thin walled feature. So make sure though that it is set to solid. In earlier versions, sometimes you would see it go to surface, and we don't want that. So rotate it a bit, and we're going to go ahead and instead of extruding blind, let's go ahead and extrude it at the mid plane. And set this dimension here to 5. Now here's the sheet metal thickness. So I'm going to go ahead and put 0.062 and hit enter, and you should see it thicken and update a little bit. But let's take a look at some of these options. If you go to the options here, again we have the symmetric and 5 inches, and then we have the sheet metal options, add bends on sharp edges. And here you can see it's the thickness, or you can say 2 times the thickness. You'll see that the bends actually automatically increase, or you can put in an explicit value if you like by typing that in. You can have them adjust from the outside or inside, whichever you prefer. And now if we go to bend allowance, by default your sheet metal settings are in your options, but you could go in here and you can set it by feature settings or part settings. If I go to by feature settings, it enables me to select K-factor, or you could use a bend table. If that bend table was brought in from previous versions, you could actually utilize that. I don't have a bend table to show you, but you have K-factor or Y-factor. Here in the Midwest, typically K-factor. Creo puts in 0.318, which is actually an exceptional size, kind of the sweet spot. That is adjustable though, and you could Google K-factor if you want to see the equations and how that is calculated. But let's stick with K-factor, and I'm going to go ahead and hit the green check mark to apply. So now we could actually see our sheet metal part. What we're going to do next is let's take a look at the Flange tool. Click on Flange, and before we select any options in here, go ahead and glide over this upper edge on the right and click. You'll see it will immediately pop out a flange. You see these are drag handles. Grab the middle one right here and drag it up to get it to 270 degrees. Now if you can't get the exactly 270, just double click on that dimension, type in 270 so it's sitting vertical. Now go ahead and grab this one right here, and you can see you can drag that down. Let's get that to a 1/2 inch though. We'll just double click on the dimension, type in 1.5 and hit enter one time. Now you'll see little handles here. This is to offset. Grab this, drag it in. You'll see immediately a dimension appears. We'll type in -1 for that one, so it's 1 inch off of that edge. And grab this edge and drag that one in, and we'll look at making that -1.5. All right. Now, a few more details. Let's zoom up here, and you can see what we have going on is a rip feature between the tube. Depending upon your application, RIP is very useful for sheet metal countertops, stainless steel countertops that are going to be used for either food service industry or medical grade. And that's just so you don't have any corner that organic material could get trapped in as the table's washed or something spills on it. What we're going to do is we're going to change that. You'll see you have the relief right here, and you can see it's set to RIP. And you have both bend relief and corner relief. So if we had a corner, we could change it different from the bend relief. But let's keep it on bend relief. And I'm going to hit the little arrow to the right. And you'll see you have stretch bend. And this is a pretty marvelous little tool. And you can see there, as if it wasn't, as if there was no relief cut put in whatsoever, it actually bends the sheet metal, gives you that little ripple effect. So you have the ability to change that. Or you could go to rectangular. Rectangular is typically used for if you laser or water jet or plasma cut something, it's easy to make that. But if you're die pressing something, obround is the more likely one that you would choose, simply because the wear on the die would be reduced due to the radius. And that could vary depending upon, again, your application. Now here you could also adjust how you want the thickness to be determined. You could say, let's have it at 0.5. That won't work, that's really big. But you'll see there's 2 times the thickness. That one, there's not enough space in there. But again, just go with thickness in this one. You could change it or adjust it on either side. Let's go ahead and hit the green check mark now. Before we do that, just so you know, there's some more additional information there. What we would put in just by dragging the handles. A lot of these were automatically formed. Here's actually a sketch where you can adjust it, and so on and so forth. I'm going to just hit the green check. And so now we have our sheet metal flange. Let's talk about putting some holes in on this angled flange. To do this, select the face, go to Extrude, and let's go ahead and draw a center line. The reason I'm going to put a center line in here is just simply because I want to mirror across the holes that I create. So I'm going to go to the circle tool, and right in this upper left quadrant, click and drag out a circle, middle click 2 times on the wheel, make the hole 1 inch in diameter. And then as far as dimensioning, I don't like any of those dimensions that it's given me, so I just go to the dimension tool, select the center point to this top edge, move over here to the left and middle click, we'll offset it 1 inch, and then click on the center point to this front edge, get in this vicinity up here, middle click, make it 1 inch. Now middle click 2 times to get out of any other tools, and select the circle that you want to copy, go to the mirror, and now select the center line that you drew. And now you should see it mirrored to the other side. Hit OK. Now by default, it's going to go ahead and cut smart enough to do that most of the time. It's removing material. You have options. You could have it go through all. I'm just going to leave it at the explicit value simply because I just want it actually, I want it to end at the end of this sheet metal. I don't want to go through anything else if I ever build on additional flanges. They also have here where it's going to automatically create the cut as if this hole was created in its flattened state. If it was created at the angled state, you would actually see little sharp corners on these elliptical type cuts. And with that on there, it automatically makes it straight as if it were cut that way. And this is the ability to adjust it dependent upon your perspective. So really nice set of tools they have there for that. Let's go ahead and hit the green check mark to apply. All right, now let's say we want to make a big center cut right here that spans on the 2 faces. We want to do it while it's in its flattened state. So it's basically folded with the hole in it. Here's what you could do. Go to the unbend tool. Now the unbend tool grabs everything by default. Maybe you don't want all those, but we could make adjustments. Right over here you have, it's the automatic reference. Turn that on to manual, and this enables you to select just specific entities. So I could click on this radius right there, and it just flattens that one out. The others are not flattened. So for example, if you want to make folding stages, this is a good technique. Anyhow, let's go ahead and hit the apply tool. And now I could select that face and go to extrude and continue to draw a circle right at the center there. Nice big one. Middle click. We'll make it 3 inches in diameter, and now hit OK. And again, it's going to cut it through for us. We'll leave the defaults as is, hit the green check. Now to bend it back, we just select bend back, and it will take all the bends and use that. Remember, you have the ability to manually do that too, and again, that's if you're trying to make folding stages for a drawing. And there we have our sheet metal part. Now if you wanted the flat pattern, you could do two things. You could unbend it, or you could go to flat pattern, and now you can see the pattern in its completed form. Okay, and that concludes this exercise. In the training guide, you'll see that then there's an additional part here, Lab 17, and give that one a shot. And it goes through some instructions. I'm going to go through it really quick. You can see it's 5 inches. It actually has a radius built into it. So note that you could build this with a radius. And it comes out, it's kind of like for a hose clamp. And so let's see how that's done. So I'm going to go back here. I'm going to start a new sheet metal part. Start off with sheet metal and call it L17. Hit OK. And I'm going to start off the front plane. Go to Extrude. Brings up my sketch tools. I'm going to draw the circle first. And I'm going to take a look at the training guide. Let's see what that's 1 point. That's actually 3 inches. Zoom up, and then you could use the center rectangle tool. Lock that into the center, draw this out, and make it 5 inches wide by 1.5 inches thick. Now, you could do a couple things here. If you wanted to salvage this, you could right-click and convert it to construction geometry. If you delete it, then it's kind of an open geometry. You might mess up some things here. So I'm just going to transform that to construction. Now for these, we want to trim these segments out on the inside. So go to Delete Segment, and you could just click on these edges here as you go around, or you could scribble through them. But be careful if you scribble through them. You could lose symmetry by scribbling through these construction lines. So avoid that. I would recommend avoiding it. I'm just going to go through here and get these done. Make sure there's nothing left behind. Middle click. You could move your dimensions however you like. And now you could go ahead and hit OK. And now we're going to, once again, we'll go with symmetric. And we'll make it, I think it's 2 inches in the book, the green check. And so there you could see, if we just check with the flat pattern, or if we unbend, there's our flat pattern. I'm going to cancel there. I just wanted to preview it. And just like before, if you wanted to put any additional features in, you could go in and you can make cuts and so on and so forth. So if I click on this face and extrude cut, say I wanted to get a centered piece of geometry, I could go to construction mode and line, and I could click from here to here, and now off of that I can turn off construction mode. Actually turn that off, go to circle, and now I have a centered circle. And we'll just make that 0.5 and OK. And I'm going to have it go through all. Apply. You could use your flange tool again if you wanted to give that a try. Select this edge, flip that up by middle dot. Let's say we didn't want it to go to 70. Let's say we want it at like 300 degrees. You could leave it just like that. You could drag these off. Not that you would want that, but take that and make any adjustments. Say we want to make it 1 inch in height and hit apply. Now with this one, I just went with the rip, but if you wanted to edit it, you could right click here in the model tree and click on Edit Feature. And again, go to Relief and select Abound and apply. You do have the ability to mirror some entities as well. If I were to click on the flange, and if I go to editing, we could go to mirror. And I'm going to turn on my planes here. I had them off earlier. And the mirror plane, I'm just going to select this plane in the center. And let's see if we'll make it a dependent copy. Hit apply. And there we have it mirrored to the other side. Okay. You could also use the flange for, if I select the flange here, I could select this edge here. And we could bring it around underneath. Just be aware it might not be exactly what you want. I'm going to cancel out of there. But there we go. And if we just want to double check, we can now go to flat pattern or unbend. And there's our pattern. Let's say we do apply the unbend. And now we're going to go ahead and make the drawing for it. So let's go to New, Drawing, and we'll call this E17. And I'm going to go with the empty with format. If you want to send this to a water jet, for example, you could just go pure empty. I'm going to go with empty with format and go with a very large size. I'll go with maybe a C should fit. Hit open and hit OK. I could right click in general view, hit OK, click to drop it. We're going to go with the, let's see, I think in this case, I believe we're going to want the top. No, there we go, the right. And now we could go to scale, and let's make sure it's 1:1. And hit OK. What I neglected to do, let me double click on that again. And a view display, make sure it's set to, you could go wireframe or hidden lines or no hidden. And tangent edges, we'll put them as center line just so you get this. And then turn off your plane display. And there we have our file, which if we want to send it out to WaterJet, you could actually turn those off. You know what, honestly, for WaterJet, you don't want those hidden lines. So if we go to View Display, hit None. There we go. And now we should be able to just take this and do a File, Save As, and do a export. And then DXF is the typical file type you might use for WaterJet Cutter. And we'll preview it. Looks good. And go ahead and export it. And that concludes this exercise.